This is about the state of the oceans, which is dear to me because I'm a diver, and where we are and what we must achieve in ocean health. Carl Gustaf Lund, welcome to the DS.
Thank you very much, and thank you for Sally and Chip for inviting me. It's a pleasure to be here. I thought I'd walk through some of the issues that we're dealing with in the ocean, so if we can load up the presentation right now, it would be great. We basically have a situation, I think, where a lot of us have talked about what's going on in renewable energy, what's going on in terms of policies in this country. I thought I would take you out to the ocean, and if we can get the presentation, to give you a little bit of a feel for what we are doing. Now, I thought I'd also give you a couple of words about what is the International Union for the Conservation of Nature. Some of you, when I've talked to you, haven't really heard of us much. Also talking about the carbon flow. We had, I think, a good sort of presentation of the alchemistry of carbon yesterday, but it was largely terrestrial, so I think I'll say a few words about the ocean side of it. Then also talking about ocean warming, acidification, and what we're now starting to see also, deoxygenation of the ocean. I was also asked to talk about the health, so how can we do that without talking about plastic? And of course, plastic being a carbon product, it's something that affects us all as well. And then finally, saying a few words about renewable ocean energy, which I haven't heard much about here either. So that's a lot to go through, so bear with me. You might find it, I'm rushing through, and also I have a strange accent. It's Swedish, in case you didn't pick up on that already, so you'll have to suffer that one as well. Anyway, here's a few data about IUCN. So in some ways, we're the voice of nature at the UN and many international fora. And we're a very democratic organization set up to really represent both nations and non-governmental groups across the globe. We do things like the Red List of Endangered Species. All the World Heritage sites dealing with marine sites, for example, come to my program. So those are a few examples of what we're up to. My program deals with issues all across the global ocean. We tend to be, in some ways, the conserver of last resort. So here in the US, of course, you have a lot of very good groups, which means they are handling the vast majority of ocean-related work here. We tend to specialize in parts of the world where there's less ability and less resources to do it. So these are the three main areas of work in my program. One is to do with what happens in the coastline. That's where most of the conflicts with humans are. That's also where many of the opportunities for improving the way we're managing exist. We also deal with the global commons, be it polar regions or the high seas. That's about half of the planet that we're responsible for here. And then finally, some of the emerging threats, and that's where I will talk a little bit about ocean plastic. So the carbon flow in the ocean, I think we have some notion that the carbon is an important factor also in ocean life. But I think few of us have the sense of how complex it is. So this graph tries to explain that a little bit in some of these flows. It's only in the last few years we recognize the fact that much of the primary productivity in the ocean, which is in the surface layers, isn't actually reaching the bottom. So a lot of what is being produced is recyclated and goes up and down continuously. And there's lots of organisms that survive throughout the water column taking care of this carbon. Whereas when you have big things like a whale falling, these type of organisms can't really cope with it. So it actually turns out a significant amount of what is stored on the bottom comes from larger animals. And it might very well be that restoring fish stocks is in some ways the best way we can capture more carbon in the ocean. I think we all agree that we need to get some CO2 out of the atmosphere. If we could only build the bottom layers of the ocean by, let's say, a meter or so, that would completely change the carbon dynamics. So restoring ocean health is actually restoring our health. Also, every second breath we take comes out of the ocean. So this is a fantastically important part of how we sustain life on this planet. Now, most of us think about CO2 as something we've been putting out for a long time. But in fact, it's impacting the oceans in lots of different ways. I'm going to talk a little bit about ocean warming, ocean acidification, which is the chemical solution of CO2. Much as we have fizzy drinks, that's actually what we're doing to the ocean. And the oceans are now 30% more acidic than they were at the beginning of the Industrial Revolution. And of course, with all our other practices, farming, sewage, and other things, we're also consuming more and more of the oxygen in the ocean, and that's then leading to a deoxygenation of the ocean. So just to give you a little bit of a sense, we hear a lot about restoration of forests as one of the key ways of dealing with the carbon flows. But it turns out that tidal flats, for example, if you look at this graph, they're in the lower part of it. Might be hard to read in the back. We basically have mangroves, tidal flats, seagrass beds being some of the most efficient ways of capturing carbon out there. And this one, I think, gives you an even starker reminder. So even if restoring grasslands is incredibly important, restoring coastal habitats is even more important per hectare. Last year, we did a report, about 450 pages, talking about what's happening with the oceans in terms of its warming. Most of us might not have missed the fact that the coral reefs around the world are dying. Just in the last year, we've lost as much as half of the coral reefs of the Great Barrier Reef, for example, which we consider being one of the best managed reefs in the world. But we're now also seeing this spreading across the globe. So basically, from the smallest creatures to the greatest whales, from the shoreline to the middle of the ocean, from the surface to the bottom of the ocean, we're starting to see effects of warming of the ocean. And this set of small maps tell you the story of how the oceans are warming. And in fact, 97% of the excess heat that we produced in our consumption has ended up in the ocean. So most of us complain about hot weather, and right now in Switzerland, where I am, it's over 100 degrees, and we have no air conditioning, so that's not a great thing, and I'm going back there tomorrow. That's the red line there. That's the small part that you see at the bottom. The actual blue lines, that's what's come into the ocean. So the story is we would be very bad situation if we didn't have the ocean. On average, the temperatures would have been as much as 36 degrees Celsius warmer across the globe, which is in the order of 80 degrees or so warmer everywhere in the world continuously, which means large parts of the world would actually be uninhabitable. So that's actually a really scary part of the story. Now, fortunately, the oceans are there and they've helped us, but the end result of this, I think, is we are changing the oceans in a very dramatic way. Here are a few examples of what's actually happening in the oceans right now. I won't go through all of them, but just to say it is quite a worrying story. So ocean health is now very much impacted by what we're doing in terms of emissions of CO2. And as I mentioned, the other aspect of this, which we're starting to wake up to, is ocean deoxygenation. We're actually losing the amount of oxygen. So much as if you're in a room which is crowded and there's no ventilation, we're now starting to see parts of the ocean being less and less habitable for a number of species. So we're actually shrinking the habitat. We're compressing the habitat for a number of species due to this fact. And of course, these things are synergistics. They actually work together. So various aspects of this are now creating situations which are more and more difficult for certain ecosystems to survive. And just to mention that ocean acidification now is a certainty. It's actually very simple chemistry. You push CO2 into the ocean, you will have an effect. And this is starting to be quite widespread. It's going to have a number of significant effects. So over time, this is something we really need to be concerned with. So that's the dire climate story. I will now switch over and talk a little about ocean plastics. Now, we all consume plastics every day. Most of it, when we think of it, is the macroplastic. It's our cups and on the tables, for example. But a very significant part of it is also the micro part of plastics. Most of us don't really think so much about that side of it. So I'll try to tell you a little bit about that story. But just to tell you where the ocean actually absorbs the plastic, well, it turns out on the surface, maybe what we observe is 15% of it. Another 15% would be in the water column, and the vast majority sinks to the bottom. Some of this plastic will go up and down during its life cycle as well. So where's the microplastic coming from? Well, it turns out a very large part of it comes from our clothing. And I think if we all look around, we pretty much all have something of plastic on us. Well, if nothing else, you have a badge on you which has plastic. And all of this releases small pieces of plastic all the time. A very large amount of this makes its ways into waterways and eventually up in the ocean. And we don't really have mechanisms for dealing with that very well. The other huge source of this is actually tires. So what we do when we're driving around is releasing more and more plastic. So a lot of us think of tires as mainly made out of rubber because increasingly we have large amounts of plastic in our tires as well. And then we have something we call urban dust. And that could be all kinds of things that we're using in the household, for example, that emits small amounts of plastic. Now, US was one of the pioneers of doing away with small pieces of plastic in various types of healthcare products like toothpaste or scrubbers and things like that. Well, that's actually 2% of the problem. So we're telling ourselves we'd solve the microplastic problem, but in fact we'd solved 2% of the microplastic problem. So we still have a long way to go there. Now, why would we care about microplastics? Well, in fact, it's making its way into all kinds of products that we depend on, not to speak of all the wildlife around us depend on. And this is just to give you hypothetical pathways. In many places, we've now looked at mussels, for example. It turns out every single mussel actually has plastic in it. And that's just looking at the microplastic. We look into nanoplastic, the situation is even more dire. So nanoplastics actually goes through our membranes. Right now, we don't even have the way of analyzing if we have microplastics coming into our bodies or not. We actually don't know what kind of health effects this has. We know that plastics is associated with about 2,000 different types of chemicals that we have as additives in the plastic. So this is another pathway of bringing in chemicals into our bodies, which, as if we look at history, has generally not been a very good thing for us. So who is to blame for this? Well, it's always good to have bad guys, right? And this country has been pretty good at pointing out some of them. Well, in this map, it actually is a pretty convincing case that managing the macroplastics is a huge task ahead of many developing countries. China being the biggest emitter right now, Southeast Asia being the part of the world where about half of the problem resides. But even parts of Africa has a huge task ahead of it to really clean up its act. Now, the interesting thing here is to note that the US has done a very good job when it comes to dealing with the macroplastics, but now micro is actually a bigger problem. So this is where the new efforts need to happen, and this is where we need to see much more innovation, finding new technologies to deal with this problem. For sure, there are ways of dealing with it, and there's always a technological solution. It's more a question of what is it going to cost, and are we prepared to pay the price? So this is our strategy to deal with it. We think there's a number of guidance materials that are needed to set standards and help industry do a better job. A large part of this is education, changing behavior, particularly in developing countries. And then it's improving the governance. How do we actually do this in such a way that we avoid having this problem in the future? So that wraps up the plastic. And then I thought I'd talk a little bit about the renewable ocean energy. Sorry, this is sort of a quick walk through. But just to say, 71% of the surface of this planet is ocean. Obviously, a lot of the incoming heat from the sun will end up in the ocean. In fact, proportionally, I think it's even bigger than what ends up in land. So that's why we need to look at how can we harness some of that energy in a renewable way, in a sustainable way, so we avoid these type of problems. So what kind of energy are we looking at? Well, there's a whole slew of different ones. The first two ones, the wind-based ones, I think we've all heard of, and the tidal ones have been built in a few places. Those are the two ones which we put most of our efforts into so far. There are a number of pilot schemes in terms of wave-based ones. I think they've not worked so well, maybe. There's ideas about currents. We say there's about 100 times more energy in the currents than all the potential and existing hydropower on land. So ocean currents is potentially a very large source of energy as well. There's also the ocean thermal energy conversion. That sort of looks at the difference in heat, so sort of a heat pump type of approach. There's the difference in of salt salinity. So there's one plant, I think, in operation looking at that as an osmosis. And then there is biomass, where we basically grow algae in particular, maybe even make fuels of it. Right now, with the gas prices we have, that's a pretty dead industry. And then we've now heard about the solar one on putting them on canals. One would conceivably also be able to do that in the ocean. Just to give you a little bit of a sense of what the issues are. So one of the parts of the problem would be how reliable is it? So what percentage of a grid could you, for example, have under different types of ways? And there are certain things like biomass. Ocean currents are a little bit more stable, whereas wind is more variable. So that becomes an issue in terms of how much you could use of it. Another thing is how easy do you move it around? How useful is it in terms of being tied into certain types of things? And is it discontinuous or not? And then eventually also then looking at where are we in this process? And just to say, I think when it comes to the commercial side, we're pretty much there with wind and these barrages across certain types of estuaries. But there are some significant environmental problems with them. We recently released a report on that very topic. What's the way of turning blue energy into green. For those who are interested, I'm happy to discuss that further. So with that, I just wanted to say my sense is that renewable ocean energy is a potential that we should tap into. However, there's a number of significant environmental challenges that we're facing on this one, so we should not shy away from those. Any energy needs to stand on its own two legs, and eventually, I think this is something which could be of interest to many of you in the room. Thank you very much.